Yeah, well, we're at the start of the Celtic there now.
Okay, thanks Colin. Starting now. This is the bottom here. The top of the graph is where the tow body is. The graph shows 100 metres of depth per division, so probably about 820 or 830 metres. Yeah, these are marks. These are fish marks or particles or things in the water column. Yeah, Orange Roughy are a more difficult target for fisheries acoustics. One reason being they don't have a gas-filled swim bladder. So the echoes we receive from Orange Roughy are quite weak, and you have to have a very quiet system in order to pick them up.
Orange Roughy are not unique in their long lives. At great depths, research has shown that most species grow slowly to match the slow pace of life needed to survive down there. There's fallout from fishing any single species, and that many other animals are affected or caught at the same time. And the impact on these populations can be very significant.
Really unusual green eye. It's a female Seekie shark.
The deep ocean is home to an extraordinary array of deepwater sharks, such as this Seekie shark. And in recent years, scientists have noticed a very alarming drop in their numbers. The more information that can be gathered about the whole web of life on the seabed below, the better. While the weather forecast is poor, the crew have no complaints. February has been very kind so far. While the sonar has revealed fish-like echoes deep underwater, it can't tell for certain that they're from Orange Roughy, nor can it tell how many fish may be down there. After the long hours of detailed survey, the team now need to absolutely identify what fish are causing these echoes and how numerous they are. To do that, the Marine Institute has teamed up with one of the first trawlers to find Orange Roughy in Irish waters, the Mark Amy. Her job is to follow the team onto each sea mount and fish through with her nets, revealing the true sources of the sonar echoes. Then some marine scientists aboard the Mark Amy will analyse each catch in detail, measuring length, weight and finally age. The age of the fish is taken from the fish's ear bones, which have growth rings laid down each summer, rather like tree rings. 10 rings means 10 years.
Once we have a segment of acoustic data and we fished through that ground and we just look at the catch, we allocate, we ascertain how the catch was distributed between the various species, and then you assume, for instance, if 30% of the catch is Orange Roughy, 30% of the echo that you have in the acoustic data is correspondingly Roughy.
So far, the team has been very lucky with the weather, but some winter storms are closing in.
It's quite difficult, as you can see. There's a bit of a swell run at the moment. It's quite windy. It's sort of 40 knots and there's about a 5 metre swell. So yeah, it's really good that we got it back in one piece. Because the weather forecast for the next sort of 12 hours is looking pretty bad, and we had to make a decision whether to bring it in now safely or to risk it later on. So it's always better to err on the side of caution and bring it in early.
Up to now, the weather's been good enough to use the water sampler and the sonar, as they can withstand fairly heavy seas. But the final piece of equipment, and the one that everyone's anticipating, can only be used in very calm conditions. This ROV, or remotely operated vehicle, will carry a camera to the seabed and reveal to the scientists the hidden world below.
With the ROV, video obviously gives you the most detailed information, video and digital stills. But in general, video would be the best resolution of information that we get. And normally, to get good video, you have to fly within about 3 meters of the seafloor.
There is 5 scientists on board at the moment that their work would solely be based on the results from the ROV. Also 2 operators, so 6 people in total. So there's quite a lot hinging on using the ROV. So we're hoping we can get in the water as soon as we can.
We've been out in a good force 10 or 10 to 11, and pretty bad seas. 9 to 10 meter swells. So really dirty, but she's comfortable. She just nods away and just bides her time there, and we wait for it to pass over.
We're very lucky in the fact that if weather can stop the deployment of the gear, then we can still work away very comfortably. There's always plenty of data processing to do, and just getting ready for the reports. And so there's always plenty to do, even when the weather's bad.
Fabio Scaghetti, an Italian computer modeller, is checking some of the search results against a remarkable 3-dimensional map of Ireland's continental seabed.
For example, you can see when I go in the tracks we have done, all these tracks here, and this is CTD cast we did, and this is the peak where we have surveyed them, and it's just so temperature and salinity.
The result of years of research by the Marine Institute and the Geological Survey of Ireland, this uniquely detailed map, showing all the curves and canyons deep below, is a remarkable resource for all future explorations of this region of the Northwest Atlantic.
In fact, Ireland is probably the leading country in the world at the moment in terms of the coverage with multi-beam maps of its offshore territories. So it's something to be very proud of, I think.
3 days pass before there's a break in the weather. With cameras primed, the ROV is ready to go.
Very relieved to finally get it. Well, it's not in the water yet, so I'm not really counting my chickens yet, but when we see the seabed, I'll be a bit more relieved, I think.
Finally, yeah, we get a chance to get it in, finally.
The crew and the scientists are excited at the prospect of getting a good look at the deepwater world of the Orange Roughy.
54.133 west. Okay, thank you.